So dear friends, we have a problem on application of a chi-square test. So according to the library stock report, the textbooks of mathematics, drawing, mechanical engineering science appeared in the ratio 3 to 5. Okay, respectively. Now, in a 100 randomly selected textbooks, the corresponding numbers of each category of textbooks were 24, 14, and 62, respectively. Test at 1% level of significance whether the differences between the observed and the expected number of books are significant by using a chi-square test. So here we are going to use a chi-square test to uh, check whether the differences between the observed and the expected number of books are significant by using, obviously, by using a chi-square test. So what we do, the solution is that we know that the total number of books is 100. That's what we were told, that in 100 randomly selected books, okay? And the expected ratio is 3 to 5. So that means you have math, you have drawing, you have math. So this is 3, this is 2, this is 5. So meaning 3, math takes a proportion of 3 out of 10. Drawing takes 2 out of 10. Math takes 5 out of 10. So the expected mathematics, so this is what we are going to do. We are going to draw our table here. Okay. And put our math here. We have our drawing and our math. So we are saying for us to get we have anyway, let's put the observed. So the observed here was 24, 14, 62. 24, 14, 62. And then we need the expected. So the expected here would be now the proportion of math to be 3 out of total, which is 3 plus 2 plus 5. Then this we multiply by the total. Okay, the total, which is 100. So what is that? This is going to be 3 out of 10 times that, and this would give you 30. So the other one would be 2 out of 10 times 100, and then you'd get 20. The other one would be 5 divided by 10 times 100, and that is 50. So that's how we are getting these values. So those are the expected values. And then to calculate the chi-square statistic, we said we have the observation, observed values minus expected values with square divided by E. Then, of course, E is the expected value. Then we sum all those data points. So what will that be? That means my observed is 24 minus 30, which is expected. I square divided by 30, and this is equal to 1.2. For drawing, its chi-square value, we have to calculate for math, for drawing, and for mechanical engineering science. So for drawing, we have the observed value as 14. Okay, so the observed value is 14. Yes, is 14, and then expected is 20. So we just get 14 minus 20 we square divided by 20, and our value is there. The observed for mass is 62 and the expected is 50. We divide by 50 and our value is that. So the chi-square will equal to x1 square plus x2 square plus x3 square, and this is 1.2 plus 1.8 plus 2.88, and this is 5.88. So this is the calculated chi-square value. So calculated chi-squared value is equal to 5.88. So let's check for the critical value from the table. But what are the number of degrees of freedom? Number of degrees of freedom is equal to the number of categories, which is 3 minus 1. So the number of degrees of freedom will be 2. So go to the number of degrees of freedom is 2, and we check on the level of significance. So the chi-square critical value is 9.210. So that is done. The significance level is that, and the value is 9.21. So what we do is to compare, we compare the calculated chi-square value or chi-square statistic to the critical value. So if I have my number line here, and this is 0, I have my 5.88, and I have my 9.21. So the critical one is above the chi-square statistic that we have calculated. So this is outside the rejection ratio, region. This 5.88 is outside the rejection region, and therefore we fail to reject the null hypothesis. So we are saying we fail to reject the null hypothesis. This means that the differences between the observed and expected frequencies are not statistically significant at the 1% level. And then the conclusion, the observed differences in the number of books in math, drawing, and math categories are not significant at 1% level. The observed distribution is consistent with the expected ratio of 3 to 2 to 5 respectively. So this is how we can deal with this problem of the chi-square, and then we get the answers and grab our marks. Thank you.